Hello, it's Michael here again. Welcome back to the Joy of Code. Today I will tell you a bit about errors and how to deal with them. If you have followed along with the series so far and you've done the programming exercises, then I'm sure you will have seen quite a few situations where you got errors in your program. And it's initially not always easy to deal with them, and especially when you get runtime errors, it's not always easy to find out what the system is trying to tell you when you get an error message. So I'll tell you a bit about that today because it's essential for you to be able to deal with errors. We all get them, and that's part of life, that's part of programming. It doesn't mean that you're a bad programmer. You just have to learn how to interpret them and how to solve them, and that's what we'll look at now. The first kind of errors that we have are called syntax errors. And syntax errors are the ones that you first see most of the time, and we'll have to look at those. And the next kind of errors, very different class of errors, is called logical errors. And I will try to explain the difference to you in a moment. There is a bit of different terminology floating around. The logical errors are sometimes also called semantic errors, or sometimes they're called runtime errors. That is all roughly the same thing. Logical errors is more the logical description. Runtime errors is a description based on when they occur, because the runtime errors, as the name suggests, we see while the program is running. If we want to distinguish that from syntax errors, sometimes the syntax errors are called compile time errors, because those are the errors that we see when we click the compile button. That is a bit less common, so what I will usually use, I will call them syntax errors and runtime errors. So these are the two kinds of errors that we will examine now. And we can maybe make that a bit clearer if we look at something not in Java, not in programming language, but in natural language, let's say in English, because we have the same distinction there. For example, look at this. Look at these words, and we can ask, is that a correct sentence? Red is the when light, and you can see, of course, no, that's not a correct sentence, that's just garbled up, this is just nonsense. So no, that's not a correct sentence. And then I can mix that up and say, okay, is it now a correct sentence? And you look at it, say, no, that's just rubbish as well. Now look at it, is this a correct sentence? Cross the intersection when the light is red. Yes, it is. Well, and it isn't. The problem is, now this is a correct English sentence, cross the intersection when the light is red. It's grammatically correct, but in fact what it's telling you is wrong. You shouldn't cross the intersection when the light is red, you should cross it when the light is green. So this is actually wrong, it's telling you something wrong, but this is wrong in a very different way. The first two examples, it was just wrong because it wasn't an English sentence at all. And now it is a correct English sentence, but it tells you something that is incorrect. So this is an error of a very different kind. The first two were grammatical errors, and now it's grammatically correct, but it is a logical error. And that is so the first two were syntax errors. It was just incorrect English, and now it's a logical error. And we see the exact same in Java. So we can look at some examples. If we look at source code in Java, in Greenfoot, here I have picked a problem, a project that we have used before, and we can look at a number of syntax errors. So, for example, here, if I remove the semicolon and I forget to put a semicolon at the end of the line and I compile, I get a syntax error. So what happens then is the line where the error is highlighted, and so you should pay attention to that line. There is a red marker where the compiler thinks the error is. Syntax errors are picked up by the compiler. So they are actually the errors that are much easier to find than the logical errors. And then the very next thing you should do is pay attention to the area down here in the editor. It gives you an error message there. It says semicolon expected. And if you're lucky, like in this case, the message is fairly precise, and the location that it points to is also fairly precise. So just put a semicolon there, and that was correct, and now it compiles again. That is a lucky case because the syntax error messages are not always that precise, and sometimes they are wrong. For example, if I here, well, this is actually another example where the message is good. If I misspell the method name and then I try to compile it, marks this, and then it has here a message saying cannot find symbol, method change transparency, and there's a misspelling. And then it says maybe you meant this one. This is, by the way, not standard Java that is producing this message. That is Greenfoot. It gives you a hint. And in this case, again, the message here is really helpful. It points exactly to the source of the problem. So pay good attention to the message that you get at the bottom of the error editor. And I can fix this. It is not always that clear. For example, if you forget a closing bracket here and then you compile, suddenly you get an error message here where this line is highlighted and it just says illegal start of expression. And when you get this illegal start of expression, that is a message that is not really very helpful. So that essentially, that's a very technical message where the compiler just gets completely thrown and says, well, I don't know what's going on here. So the message is not helpful, and the position is misleading because it highlights this line where the error is not in this line at all. The error is up here where there is the closing bracket missing. That happens every now and then. So sometimes when an error gets reported in one line, the actual error is actually a few lines above. So if you can't see the error in the line where it's reported, look a bit above. Errors with brackets, actually also the editor of Greenfoot tries to give you a bit of help. And if you pay attention to this background coloring, you see when I remove the bracket, then actually it looks wrong. In fact, you can go to the options and preferences and make the colors a little bit stronger if you want to. Then you see the background coloring much stronger. And suddenly here you see, methods usually have this yellowish background color. And here suddenly this method goes all the way down here and doesn't end here where it should end, and that gives you a hint that something with your brackets is wrong. If I put the closing bracket in again, that all looks much more normal again. The same if I have one bracket too many. If I put another closing bracket in here, the compiler doesn't help you very much. If I click compile, it again reports the problem in here and says class interface or enum expected, which is a message that is completely misleading. It has nothing to do with class or interface. The actual error is that I've got a bracket here that shouldn't be there. And again, the problem gets reported a few lines below where the actual problem is. The comment here gets completely ignored, so it goes past here and then there it is thrown. So this message, if you can't make sense of it, look carefully around the area, also a few lines above where the problem gets reported. And of course, pay attention to the background. Here the whole background is white suddenly, which shows you that Greenfoot actually thinks the class is ending here. So if we remove this, it looks better again. So these are syntax errors, and they are reasonably easy to deal with, in that they're not always easy to solve, but they're easy to find because the compiler will point them out straight away. Okay, now logic errors. Logic errors are the much nastier errors because if you have a logic error, that means syntactically your program is fine. It does compile, and it just something happens at runtime when I run it. For example, let's look at this. Here I've got my change transparency method, and here when my ball is completely transparent, I remove it from the world. Let's say I want to then, when my object is removed, I want to put a new one in. So I say get world add object, and I create a new ball with direction 0, and I put it into the world at 0, 0 location. So this says, I remove myself and I add a new ball into the world straight after. If I compile this, the compiler's happy, says no syntax errors. In fact, remember, it doesn't say no errors, it just says no syntax errors, which means, this is grammatically correct. But when I run this, now I compile the rest of the project, and I run this and I click in here, there's my ball. It fades slowly away, and when it is completely transparent, there suddenly we get this window popping up here with some red text written down here. That is a runtime error. So here the program ran, compiled without problem, it ran for a while without problem, and suddenly something happened where it says I can't continue, there's something wrong here. And then when you get this, what you should do is, what you get here is called a stack trace. In fact, the stack trace here appears twice. That is because I have actually run that same program before I started this recording. So I have done the same twice. So I have here the output twice. So what you do in the stack trace shows in the first line the error message. The mechanism that Java uses to report errors is called an exception. So what you see here, you see always something with an exception. We will talk about exceptions in more detail much later in this course, but just remember for now, an exception means the system is reporting an error to you. So the first line tells you what kind of error you're getting, and then the rest tries to tell you where that error occurred and how you got there. So we have here something that's called a null pointer exception, which means that some object that I was trying to use was null. And then the next line tells me where in my code I am. So that happened when I was in my ball class in the method change transparency, and to be exact, I was in the ball class in line number 76. So I can go now to the ball class, and you see I've got line numbers here. You may not have line numbers. They can be switched on and off in Greenfoot. You can go to the preferences of the editor, so to the editor tab in the preferences, and there is this option to display line numbers. If you don't see line numbers, go to the preferences, switch them on, and then we said here line number 76 is where the error occurred. 76 is here, so we know it is in this line that this error happened. The rest of the other lines here show us how we got there. We can see that change transparency was called by the ball act method, which was called by the Greenfoot core simulation in a run actor method. That is somewhere hidden inside the Greenfoot framework. So here we see there was the run method of Greenfoot was called, which called a couple of other methods, which eventually called the ball act method, which called the change transparency method, and we got up to line 76, and then it all went wrong, and we got a null pointer exception. So somehow in this line we have a null pointer exception. When you get a null pointer exception, it is almost always the case that you're trying to call a method on an object that was actually null, where you didn't have an object. So here, getWorld was supposed to give me my world object, and then I tried to call the addObject method. And what this is telling me is that the object I was using here for my method call, I didn't have an object, that was null. And the reason here is actually because I just removed myself from the world. If you look carefully at the specification of the getWorld method, it says getWorld gives you the world object of the world that you are currently in. And now, because I have here, the line above, removed myself from the world, then in the next line I'm not in any world anymore. So if I now say get my world, I'm actually getting null because I'm not in a world. So this getWorld call here returns null. And here I tried to call a method on something where I didn't actually have an object to call it on. I had null, and I tried to call a method with null, and that gives you a null pointer exception. So this is how to read what's called the stack trace. First, pay attention to the error message, and then look at the top here, find out which class you're in and which line number you're in, and look at it. Sometimes you have to do a little bit more reading here. I'll show you one other example. I have here another version, older version of our bounce example with the colored, where they change color in this way with the images. So if I let that run for a while, it runs for a while without a problem, and then at some stage suddenly, boom, there it blows up. So here I have again a runtime exception, which means a runtime error. It compiled correctly, it ran correctly for a while, and suddenly something goes wrong. And again, I go to the very top of my error output here, And if you look at that a bit more closely, there it says Java lang illegal argument exception. So here the kind of error I'm getting is a different one, illegal argument exception, and then it says, actually to be precise, it was a file not found exception, and then there's a message here that said it could not find the file button5.png. And the reason is that I don't actually have an image file called button5. I only have button 0 to button 4, so I have counted up one too far here, and that file doesn't exist, and that is something that cannot be detected at compile time. So at compile time everything looks fine, and then at runtime it says, I don't know what this file is, I don't know that file, I can't load it. And now if we try to find the place in our code where the problem actually is, if we look down, the first line down where it tells us where this where this error occurred, the file that we're in here is actually the class that we're in here is Greenfoot image. Greenfoot image in line 285. But Greenfoot image is not one of our own classes. So Greenfoot image is a class that is built into the Greenfoot framework. So we can't change it. That's not where the problem actually comes. So then we look at how we came there. So Greenfoot image load file was called from Greenfoot image init, and init means the constructor. So that was called from the Greenfoot image constructor, and that was called from the actor class setImage. That again, the actor class is a Greenfoot built-in Greenfoot class. We can't change it. So that's setImage file. So then you look down this stack here until you find the first class that's actually yours. And here we see there's the ball class. The ball class is here over in our project. So you go down this list and you find the first class that is mentioned that is actually your own, and there you look. So it's saying here at that point we were in the ball class in the change image method, which was in the file in line 44. So we look at the ball class, we look at line 44, and we see here this is the line we were in our code. So we were in ball change image line 44. We were here. And then I can see here, from there, the actor setImage method was called. And yes, we can see we called that. And then I can see internally that setImage method called a Greenfoot image constructor, which called a method load file in Greenfoot image, and then it all blew up. So these classes here, it's not their fault that it went wrong. The fault is actually in my class. So here you find the class that is yours, and you look in that line, and there we see that is when the name for the image file gets constructed. And here I should actually not count up to 6, I only should count up to 5. That was my error. But this is how you read the reporting of a runtime error. So runtime errors come actually in two different forms. One is the runtime errors that the program actually recognizes. This one here. So I tell my program to load a file that doesn't exist, and at some stage the Greenfoot system will say, well, I can't do that, and it reports an exception. It reports a runtime error, and then I can investigate it. And sometimes you have a runtime error where the program doesn't actually realize that something is wrong, where, for example, let's say I want my colors to change, and the colors just don't change, but the program doesn't report an error at all. That is then a logical error that doesn't lead to a reported runtime error. So logical errors sometimes have the result that just the program runs fine, but it just does the wrong thing. And then I have a much harder problem. Then I need to get into what's called debugging, and we'll talk about that another day when I have to find out where the actual problem comes from. But that is, logical errors are often not detected by the system, by Greenfoot or by the compiler, and then it's up to me to find them, and they just manifest themselves in the way that the program just doesn't do what I want it to do. And that's really harder to find then. So that's the way you deal with syntax errors, and this is how you read the error report for a runtime error. You will see a lot of them when you're programming. There's nothing wrong with getting errors. We all get them, but you have to learn how to fix them. Okay, that's it for today. Bye bye.